about unit testing and specifically using the LabVIEW. I'll be giving some little LabVIEW demos as well. They might be a bit clumsy because there's not a lot of room to use a mouse here, but I'll do my best. So firstly, it'd be good to find out, does anyone use the unit test framework at the moment? One? Oh, that's pretty good. Two.
Yeah, quite a lot of people here, that probably should be.
So, well, hopefully by the end of the presentation you might think that everyone should be, rather than just some people or a lot of people. So I'm going to firstly just give you a little introduction to the benefits as I see them with unit testing, and then I'll show you how to just create some simple unit tests using the unit test framework to generate some more complex tests, like user-defined tests. I'll give some basic guidelines as to what we use in my company, and a lot of it's been from trial and error really, and then I'll point you in the direction of some potentially useful resources. So I'm not going to read out that whole thing there, but if we're looking at unit testing, we've got to consider what is a unit really, and it's here it defines it as the smallest piece of testable code. I tend to look at it as the smallest useful test really to execute your code, to exercise the code. So the way I got into unit testing was like a lot of things that are good for you really that you don't do. I was forced to do it. I was working on a big project which was a safety critical application, and I was basically told by not just the bosses but the whole the regulators, you will do unit testing whether you like it or not. So I knew it was a good idea, and it was always one of those things where I thought, oh, that sounds really good, but I just don't have time to do it, and it's probably not going to bring me the benefit. Then when I was forced to do it, I started to quickly see that it brings so much benefits to the project, and as I'll go into later, there is an overhead of writing the unit tests, but I would maintain that in the long run it saves time, definitely saves time, and makes your code more robust. So the benefits, the main benefits I've got here is that it finds problems early. So you're testing stuff before system testing and before, and definitely before the product's out in the field. So an engineer who's sat writing a little piece of code typically will write the test at the same time. So they'll write a little snippet of code and they'll have a test for it. And I'm sure everybody, when they write their code, let's say they've got a little algorithm, let's just say it's a straightforward addition. If you're creating a sub-VI, you'd write your sub-VI, you put some data on the inputs, you'd run it and you see what comes on the outputs. The good thing about unit testing, using unit test framework, is it automates that. So you write the test, and then every time you've modified the code, you can run all the tests again. And in practice, when people do their little manual tests, they're not going to go through the whole application, redoing and remembering the tests that they've done. So because we're testing as we go along, it reduces the chances of bugs being introduced into the end application. It allows you to quickly locate and fix bugs that do occur. And I've just highlighted this really, but it allows regression testing. So as we're working on an application, whether you be a single developer or in a big project with lots of developers, as people are committing code and making changes, you can rerun all of those tests, and it just takes a couple of minutes, and then it gets a result. So if developer Bob is modifying some code, and it has an impact on Fred's code, when they run the test, they'll be able to see. And one that I've highlighted in bold there is that it improves your coding standard. So if you're writing code where you're thinking, how am I going to test this? It forces you to think about how's it going to be tested. It means it's more loosely coupled, and you haven't got loads of dependencies. It makes it nice and readable as well. So just some minor benefits as well is I find that it kind of aids the documentation side. So if I write a library and I write a set of unit tests and I hand the library over to someone and say, integrate this into this application, they're able to look at the tests and they can see how I was using the library to do the tests. So it shows them I'm using it exactly as I intend them to use it in the application. Also, one good thing about the Unit Test Framework is it actually comes back with a magic number that tells you what your code coverage is. So it reports basically a percentage code coverage for your tests, but you can also tie it into your requirement coverage if you're using requirements gateway or something like that. And you can actually tie it to the test results. So for the people who've done the LabVIEW Architects exam, and you go through putting lots of little covers tags, and you put them all over the code, well, that doesn't mean that the code works, it just means that you put the tag there saying it covers it. Whereas if your test result actually says that your test has passed, and that is what the coverage is, it will fail until the person's wrote the code. So it's more effective than just going through putting covers. So what is the Unit Test Framework? Well, it used to come as an add-on toolkit, and just to clarify with the NI guys, it's free now, isn't it?
Yes, I believe now.
Is that at all levels of LabVIEW?
I believe we have LabVIEW Professional.
Yep.
It's not part of it.
Okay, so it's included in LabVIEW Professional. I think you still have to tick it when you're going for your install. I don't think it installs it by default. And basically, in its simplest form, it gives you, within your project environment, you can bring up a little window that lets you configure a test that will call your sub-VI, so your unit under test, and it will call it with the conditions that you configure. It will then check the outputs match the outputs that you set up, and then it will give you a test result. So you can configure it to do multiple test cases. So if you go to simple addition, you could test that it will calculate 1 plus 2, but you can also check how's it going to behave if you put in not a number, for example. So what I'll do is I'll quickly come off there and I'll quickly create a unit test. So I've just created an empty project there. So if I just create a VI, okay, so people wouldn't, I guess, write a unit test for this unit is going to work, but if I run this, I might do a quick check and say 0 plus 0 is 0. I might say 1 plus 1 is 2. Okay, so that's how people would manually do this, and then once they've done that once, they'd never go back and look at it. What I can do is, I think I probably need to save this for now.
Quick question, why not Windows 10? Yeah?
I'm on Windows 10, yeah.
Yeah, any problems?
Not at all. No.
Cool.
What versions of LabVIEW?
This is 2014. But I've used it on this computer with 2012 and 2013 for legacy projects, and it's all good so far. Okay, so I've got a VI in my project here. So to create a unit test, it's quite straightforward. You just right click, go down to unit tests, say new unit test, and it'll work a little bit. Okay, so you see you've got a little unit test here. Just out of interest, if I put a text document here, I may need to save this first before it let me do it. Yeah, I won't save it. Yeah, it is saved. So if I drop this down on here, it's just a text file, just a tab separated file. You can open it in Excel and edit it. So people can edit these test files without running the LabVIEW environment. Anyway, so if I double click it from the project environment, it will bring up the configuration window. Okay, so there's some initial configuration which lets you point to the VI, lets you turn it off. You can skip it if, for example, you might only want to run this test occasionally. It might be intensive or whatever. So you can tell it to skip. You can, when you put the requirement ID, that's where you are tying it into your requirements management system. So we then can actually start to specify test cases. So the way that I showed you a second ago, by doing 1 + 1 = 2, if I run that there, as you normally would anyway, I can actually import those values. So, did it import them? Nope, demonstrate its cursor, I think. Do I need to save that first? Anyone, the people who do use it, understand why that's not importing
The
them?
values might be saved as default values? I think if you're pulling zeros, if you're...
No, it should return the current values that are there on the screen.
Constant RAM, whatever it's called, but
I know, I'll tell you why. Okay, so, I've got to put them as inputs.
Yeah. Forgot that too.
Yeah. Okay, so it tests the inputs and the output arguments. Now in the advanced settings, you can get it to test other front panel objects. So, now my Windows disappeared.
It's the middle one.
Yeah, okay, excellent, cheers.
The VI hasn't saved this.
I'll tell you what I'm going to do, right, I'm going to skip that. Right, so trust me, you can import it. But I still need to save the VI. And I'm going to get rid of that. And I'm going to open it up again. There's still no stuff in there. I'll tell you what I'm going to do. Apologies for this. Definitely demonstrates its cursor here. I'm just going to open up one of the example projects, which has got the same VI as I just created anyway. Okay, so here we've got add, subtract, multiply, divide, and then we've got some unit tests. So if I open up this unit test this time, sorry, this is where I've done wrong. So when you change the connector pane, you need to hit the update button for it to reload. But what we can see here now, I've got this one that's open, so we can take a look at our inputs X and Y, and it shows you them there. And then you can say what those values are, and then you can say what the expected output value is. And we can have different test cases. So here someone's doing 1 + 1 = 2, and then 1 ± 1 = 0. So you should have comments in there saying this is what I'm doing to test. But this is relatively new. I think this came in 2013. So I guess this example was written before then. So let's just, if I just close that now and run that. It's going to do a quick test. It's actually, yeah, so it doesn't have to display it as a HTML file, but it's telling me the result, so it's saying one VI was tested, one VI passed, and project coverage 12.5%. So you actually get a results window here that you can save. You can save with your build if you want. So similarly, you saw that I run that from here. You can actually run all of the tests in the project or all of the tests within a folder, and the little indicator there shows you the results. We've got a little green indicator, probably not very visible there. But if I was to run all of these, it tells us there's 7 tests. It tells you the progress as they go, and we can see one's failed already.
So all those test definitions are kept in that text readable, in an individual, a one-to-one mapping of a text readable file?
Yeah. So, and what you can do actually is from the file. So popping up with the test results here, let's get rid of that. So if so it's over there, it's telling me I've tested 100% of the project. This one down here is important. This VI is indirectly tested, because what you'll see is that one of the recommendations that I make later is don't write a test for every single VI, because you'll be there forever. So if you've got a set of public functions, you don't necessarily need to write VIs for all the private functions that it calls, because they'll be indirectly tested anyway. So write tests for your public functions, and then you'll get indirectly tested measure there, so it'll tell you all the VIs it's done. So if we go back to here, if I go to right click and say find VI, it points to the VI that it's tested. And similarly, you can go to find unit test. So any VI that comes up that's failed, so this one for example, I could go and say find VI, I can open it up. It's worth looking at the actual reason it failed. But if we look at this code here, it's, that looks pretty like a subtract function. So if we open up this is actually a good example actually. If I open up this failing test, you can actually run the individual test cases just to check them. So we see that this has failed. So I normally look at the report, but I'm familiar with this, I'm just skipping through it. It's telling us that it's expecting a value of 0 and it's getting a value of 2. So we think, well, why is that? So if we have a look and say 1 minus minus 1, expected value 0, well, that should be 2. So there, that's found a bug. That bug isn't in our code, that bug's in our test. So it does have overhead, and there is a chance that when you're writing your test, you're going to write bugs as well. So yeah, it relies on you as a developer, but once you get your tests running and they're robust, as you start to modify your code elsewhere, you can just keep running these. Every time you're going to do a build, or every time you've finished working on a library, you can run through all the tests and make sure they work. So I'll just pop back to the presentation and see where I should be. So we saw that there, just testing one simple, quite simple test. And we just created a test and added a test case and then run the tests. So, and we actually went through that example. Now, a lot of VIs, you might not want to just set up, do something quite straightforward as 1 plus 1 equals 2. You might actually have to do some configuration. So if you're going to do a test on a write to file, you might have to have a open file reference, and then at the end you might have a closed file reference. So it lets you, additionally, set up, create setup and tear down VIs. And very similar to how we set up the connector pane for the VI under test, if you add setup and tear down VIs, it lets you actually configure those inputs and outputs, and as it points them to the VI under test. So it's I'll open up that presentation, that example. And what I'll say is as this is loaded, is I don't really use this feature very often. I tend to use the straightforward little scripts that we just saw, or I use user-defined tests. So here we've got our little unit test files. we've got a tear down VI, a set up VI, and a VI under test. So if I open up read from test file, for example, here we go. So we've got a bit of a description here saying what the test is doing, and there's a single test case. Okay, so it's saying here that we don't specify these on this, we actually specify those as part of the setup and tear down. So this is where you say the outputs of this come from here and there, that you could wire up the connector pane basically. And then on the output, we can actually check the outputs of both the VI under test and the outputs of the teardown VI to build our test. So if I run these, again, there's no point doing that, you'll just see the little run script come up.
Where are your setup and teardown VIs? Are they saved as files?
They're saved, yeah, they've been saved. So if I open up that project again, so if you're doing setup and teardown VIs, I mean, you might not have to write a VI if it's just opening and closing a file reference, and you've got a VI under test which is reading from file. You can actually point to the LabVIEW VIs, I believe. So yeah, so it doesn't have to be a VI that necessarily that you write, I don't think.
So if you did point it to a LabVIEW VI, would that then show your dialog to open the file?
I've just, you know what? I should have checked that out before I committed to that, because I don't know if that's true. I think you do have to write a VI, but let's take a look. It'd be interesting. So yeah, you have to actually specify the VI. So you have to create a wrapper. So if you've got a function such as open reference, you have to create a wrapper VI around it to be able to point it. So
Can you just sort of browse it in the VI library? So just go to the path programs.
I don't know if you'd be able to find something though. If it, like opening a file
I
reference.
don't think you'll be going to the end at the point of.
No, you just write a wrapper.
I think something that will have to point to a file, for example. It can't just be
Yeah.
open file. You have the VI that contains the file name, what you need, and other conditions.
And this is why I tend not to use the setup and teardown. So I don't want to really write a VI just to handle the setup condition. If it's something such as if I'm testing a queue for example, I might do, because I might have created a VI that creates a reference anyway. So I've already got a VI in the project that could be used as the setup, and probably got a VI that could be used as the teardown. But I don't really want to write setup and teardown VIs unnecessarily. So as you'll see in a minute, I'll come on to user-defined tests, and that tends to be the domain that I work in. If I've got anything more complex than just a 1 + 1 = 2 situation. Okay, so user-defined tests, it lets you create, as I was saying, more complex tests, and this is where it's definitely a good way of documenting how a function is going to work, because of you actually working in the LabVIEW domain, and when the developer that's going to be integrating the library into the project wants to see how it works, they can open up the user-defined test and they can see that you're using blocks A, B, C. And that's the context that the VI is supposed to be used in. And it's very easy to create. So instead of right-clicking and saying new unit test, you say new user-defined test. So if I just show you here, if I just go to unit test, user-defined test, and this will actually create two things. It will create a, save that on my desktop so I can delete it. It will create a unit test file, and it will create the user-defined test. So if I open this up this time, see the test cases, you can no longer specify those, and set up and tear down, you can no longer specify those. And you actually here, at the very bottom, is pointing to a user-defined test. So that's telling the unit test framework that when you come to do the tests, you're going to call this VI. And then if we look at the VI, it has this connector pane already set up with a cluster, so you can't modify this. When the unit test runs, it checks the status of this. And this might be a good one that the NI guys can confirm for me. So what I would normally do is if I write a unit test, I might not write the code at the same time when I create the test. I might create all the tests, go off and do some coding. So I want to default those to failed. Because someone could come along and could create the test. If they leave that there, you're going to run a unit test, it's going to say, oh yeah, you've done great. But you know, until the actual test substance is there, really that should be defaulted to failed. But I've never been able to find the template file to be able to modify it.
You know, you're probably at this point using it more than I am, so I don't have anything to add.
Okay, right. So if I ever find out how to modify it, I'll let you guys know. But as soon as I write it, the first thing I do is I open it up and I say it's failed. So if I run the unit test now, it's going to say it's failed, which should be the default behaviour of the test until it actively passes. So now what I can do here is I could do something, and then I could have a decision at the output, and I could say, if that equals true, I could pass or fail. So you can build all kinds of test cases as well inside there. It doesn't have to just be straightforward pass fail. You can have a whole, you know, you can create this like you would any VI. You can have all kind of complex things going on to really exercise the VI under test. So what's probably worth doing here is if I actually open up, there's a good example in here. So all of these examples I'm bringing up for you are actually in the example finder. If you just type in unit test framework, there's loads of stuff to get you started. So user-defined test. So I'd say probably 80% of the unit tests I write tend to be user-defined tests. And then the other 20% are just straightforward test scripts. And it's very, very rare that I'll do a set and tear down. So if I open this up, open the basic one to start with. So that's saying, that's just an example like I just said. So we're doing a 3 + 4 = 7, pass, fail. Okay, and what you need to remember as well is these examples are, you know, really baby steps to show us how to use it. So don't think, oh yeah, I'd never write a test for 3 + 4 = 7. You can do a lot more testing when you code. So this is a more advanced one where they actually have different test cases and they report the reason that it failed. I tend not to go to the trouble of doing that. I tend to just use the straightforward pass fail, and if it fails, I open it up, I run that VI, and I work out why it's failing. Okay, so the general guidelines, this from my experience of using this for probably 2 years now, I would say, is don't attempt to create a unit test for every single VI in the project because of some stuff just won't need testing. And as I said before, you can find that you can actually test some of the lower level VIs by testing the VIs that are calling it. Don't expect to get 100% code coverage. If you try and get 100%, you'll be there all day thinking of every single possible test cases. I tend to aim to make sure that I get at least 60% code coverage. Did I explain what code coverage was? I don't think I did. Okay, so if I've got, just very quickly, if I've got a VI that's enclosed in an error case, or let's let's say it's a functional global, and there's a case structure and an enum, and I might test, it might have 10 states. If I write unit tests, Unit Test Framework knows how many states have been exercised. So if I only call 2 of the test cases, I'll get quite low coverage. So you can, it reports how much of your actual code has been exercised. So yeah, you won't get 100%, or it is very unlikely. So I tend to aim for kind of 60-70%, and I'm happy that I've got good coverage of my code. And just some advice as well, if you're working in LabVIEW libraries, try not to add your unit tests and user-defined tests to your library, because then it increases the size of your build, because all those files are included. So the problem you've got there then is any VIs with private scope, you're not going to be able to test from within the project, because of it won't be allowed access to it, so you'll actually get an error. So the test will still finish, it will just report an error when it's done. But as I said, your private scope VIs are always going to be called by something that's public. So if you to test those, test the public ones. And before I go on to this, yeah, as I go through this list, I wasn't sure how to spell do's. It didn't look right with an apostrophe, but then it doesn't look right like this. So apologies, English isn't my strongest point. So there's a lot more do's and don'ts. So if ever you're going to refactor some code, I'd recommend writing a unit test for that, because you can write the unit test and you can see that the code you've done works, which you probably knew it worked anyway. You can refactor the code, make your changes, move all your wires, delete things, and then rerun it, and it should still pass after the refactoring. So if you could go to the trouble of refactor some code, write a unit test to make sure that you've not broken it. If someone reports a bug and you've got to fix a bug, write a unit test, because your unit test should be able to prove that it fails, and if it fails, you know that you found the right area of code. Fix the bug, and then run the unit test, and then it will should show that you've fixed it. Anything that's a critical section of code, so if you've got a really important calculation, so it just makes sense that you're going to test those. When you've done your development for the day and you finish working on the library, just rerun all the unit tests, because I know myself that I'll be working on one area of code and I think that doesn't affect anything else, that's just local to here, and then your customer phones you up and it turns out you've broken something down the line. So you do little local tests and it's fine, but you've actually broken some code. So when you have worked on a library, rerun all of the tests in the library and then check you've not broken anything. And then if you're working in larger teams and you're working using source code control and you're working on branches, for example, so a developer could be working on a branch, they can run all their tests, check that it works, merge it back into the trunk, and then you obviously need to check that the merge process hasn't broken anything. So always rerun a unit test before you commit back onto the trunk. And then one thing, don't come up with a fixed set of rules and say I'll always do it this way. Modify your test strategy as you gain experience doing it. So I found this to be a really powerful tool. As I said, it hasn't given me a big overhead. It definitely takes some time to write the tests, but I think overall it's given me less problems on site, more confidence when I send something out to a customer, and it's just made the whole kind of the process a lot easier really. So there's some good references here. The actual NI documentation is very good, and the example finder explains really well how to use it.